Alright, this is the Chapter 7 test review, so I'll help get you ready for the test coming up this week. First thing is reminder for the vocab, make sure you have gone through and make sure you get the correct definitions in your glossary. Go with friends or family, have them ask you the words, or tell you the definitions, and then you tell them the words, or vice versa. Then review it early. It actually makes the rest of it a lot easier. So hopefully you've already started doing your vocab. If not, it's never too late to start. Make sure you start soon. First thing I want to talk about as far as the concepts are how clouds form and what type of weather occurs with certain clouds. And on this picture here, you can see that we have what happens is the warm, moist air rises from the surface, and as the air rises, it begins to cool down. And then at point 2, you can see at a certain height, the air actually cools to the dew point, which is just the temperature at which the water will start to leave the vapor form and start to condense. And we actually start to see it condense into the cloud droplets up there. Remember, those are the very, very small droplets. The water vapor condenses are these tiny particles in the air forming the cloud. These tiny particles can be anything from other water droplets to pieces of or more like dust particles that have made their way up there from dust storms and things like that as well. The next one to look at are the air masses in the front. This first slide is going to show you the different air masses, where we have maritime polar air, continental polar, maritime tropical, and continental tropical. The big thing to remember from that is maritime, that's referring to coming from over water, so it's going to be humid, and continental means it's coming from over land, so it's going to be dry. And you can think of that back in the terms of like when we talk about the continental United States, those are the United States that are all together on land. And maritime, thinking about for the ancient or in earlier times when we would actually have the maritime going across the ocean and things like that. Polar versus tropical, that's pretty easy to keep track of. You guys always think of trying to go to a nice tropical destination, and so tropical you always think of as warm, whereas if you're going to the poles, it's a polar destination, which would be a much colder area. And so it helps to keep track of which ones are which. Now, looking at the front, here's actually a pretty cool picture I found that shows the front, and you can actually see the air moving across there in the center. It's going from right to left, and you can see right where the front is at, we actually have a warm air mass that's pushing across and pushing out the cold air mass. And so it's actually a pretty impressive view. And you can tell that it's going to be a warm air mass there on the right side for a couple reasons. One, they could probably measure the temperature and see it. But the second part is if you look at the clouds, you can see it's much less cloudy, which is usually a good indication that it's going to be warmer, or it's a warmer air mass. Now, the first front we want to look at is the cold front. You can see here is that we have the cold air pushing the warm air out of the way. And so you can think of just the front as referring to whichever is doing the pushing. Whichever is pushing something out, that's going to be the one that's going to be the front. So here's a cold front, and then here's a warm front. You can see again we have the warm air pushing the cold air out of the way. Both times that we see the warm air will actually rise up a little bit over the cold air, which makes sense. We've studied how the winds form and everything else with the last chapter, and we saw that the warm air rising or always tends to rise because its density is going to be lower. This next one shows an occluded front. Occluded just means that it's not being included. It's a good way to think about it. It's not included. And so the warm air is actually occluded or blocked from hitting the ground. So we actually have warm air that's actually trapped above two cold fronts. And that actually creates some interesting conditions because we can actually then get some good rain out of that, and gives us a couple other unique things that happen there. And then finally we have stationary fronts. And we look at the stationary front here, you can see that both fronts are pushing against each other. And so they can also actually push back and forth as well. But in either case, it actually stays in one spot. The stationary front is one of those things that if you're really hoping for a school delay, you'd like to see a stationary front of fog, or if you want a school closing, you want to see a stationary front with snow. That means it's going to dump a lot of snow in one spot. Now you can see in this that it actually has a fluffier cloud, and I forgot to cover those earlier. We look at the clouds, the fluffier they are usually means the better the weather, but we also have to think about the more severe storm ones like the cumulonimbus cloud we studied in class just today, where we saw that it actually has more of the anvil shape and generates the much more severe weather. Typically, though, the more wispy they are, you can actually say they're probably going to be a little bit better weather. Now the next one is looking at high and low pressure systems and what exactly they mean. Here you can see an animation of a low pressure system. It's represented with an L on weather maps. And you can see that the air is twisting counterclockwise if you look at it from the top, and it is actually also rising at the same time. It is a low pressure, so it's going to continue to go up as time goes because it's usually a little bit less dense as well. Now, at the same time, we have high pressure, which is actually when it's pushing down and the air is actually moving away. It's actually going to also be going clockwise, the opposite direction. And these directions are both actually for the northern hemisphere as well. But you can see that it's actually pushing clockwise and spreading out. Typically, we see that with a low pressure system, there's more rain, whereas with a high pressure system, we usually have better weather. So if you're hoping for a good day during the summer, you'd like to always see a high pressure system coming through. Whereas if you're hoping for some rain, then you want to see a low pressure system. Now, looking at the next item, the snowstorms, what exactly happens during them and what's dangerous about them? Well, of course, it's going to be cold. We've known that from experience. There's high winds, and of course, there's going to be snow involved too. One of the special cases that we have with it is actually what's called a blizzard. And this is just a snowstorm with a lot of extra high winds in it. And with those extra high winds, we actually can see that it becomes even more dangerous because it's difficult to remain warm in those conditions. And the next thing to look at is what you need to do to stay safe during storms. There's actually 3 storm types that we want to make sure that we understand because they're the 3 most common ones we see here around Fort Wayne. The first one, I'm looking at the winter storms. Have supplies and keep indoors away from the wind. And if you're outside, just get inside. Not really many options on that one. You can't really find a good safe spot. But if you can't get inside, try to find some place that you can get blocked away from the wind. For a thunderstorm, you want to avoid places and objects where lightning may strike. You want to get away from it. If you're swimming, you want to get out of the pool. Even an indoor pool you want to get out of because the building you're in could get struck by lightning and it will travel right through you as well. If you're outside, crouch in a low area with the head down. Again, though, obviously, if you had your choice, you're outside and there was a building nearby that you could get into safely, it'd be better to get in someplace safe instead. And then finally, we have tornadoes. The ideal situation is you have a storm shelter or a basement. There's no basement like when we're here at school. We actually go to the middle of the ground floor away from the windows. We don't have to worry about the ground floor part, but let's say you were in the wrestling room, you wouldn't get to stay up there. They would have you go down and probably into some of the locker rooms or something like that. But definitely want to get away from windows. Don't want to be near any of those. If you're outside, lie flat in a ditch. One of the other things that is always good is to try to protect yourself by covering her up with something. The book recommends like a table if you need to. It's also good sometimes to just put a blanket over you. And finally, we will look at the different properties of precipitation. This is looking at the sizes of precipitation. That's actually the part that I really want to make sure you understand because it will show up on the test coming up. We look at the 4 major types: rain, snow, sleet, and hail. We can see that the size varies quite a bit. For rain, it would be between a half millimeter to 5 millimeters. Whereas snow, it actually varies so much it's not worth keeping track of because of how compacted or how loose the snowflakes can be. For sleet, it's always less than 5 millimeters. It's an ice pelt less than 5 millimeters, whereas hail is an ice pelt that's greater than 5 millimeters. Now, there's actually some different temperature conditions that can cause these to happen in different situations in the upper atmosphere, but the bigger part to remember is that the size determines what we call it usually when it gets down to the ground. You can see with all of these, the ground temperature is kind of interesting. First, they have rain, it has to be above 0 degrees. Of course, if it's less than 0 degrees, we're going to have what's called freezing rain instead. But for snow, sleet, and hail, we can actually get those with the ground temperature being above 0. In fact, if you think about it, if we get hail, usually we see that in the summer, the ground temperature is going to be much higher than 0 degrees Celsius, more in the 20 to 25 range. For air temperatures, you're actually going to be looking at, for rain, it needs to be above 0 degrees. If it's below that, we typically can run into troubles with that. Snow, sleet, and hail, again, those are air temperatures close to the ground. If we're looking at up higher in the atmosphere, obviously they're going to be much colder because it does need to be below 0 at some point for them to freeze into those solid forms of water. The last thing is looking at how to measure and calculate relative humidity. You can see on the left-hand side we have a close-up of a set of sling cyclometers. And if you look at them, you always can tell which one's the dry bulb and which one's the wet bulb. The easiest way to tell is looking for whichever one is the highest. The highest one is always going to be your dry bulb, whereas the lower one is always going to be your wet bulb, because the water is actually helping absorb some heat and it cools down the thermometer slightly so we get those slightly different temperatures. So what you would do is you'd actually record both those temperatures, and I'm actually going to pick a different set because these won't work for our table we have here. But I can tell you on the test if there's a question like this, the one that you measure will match up to something on the table. But let's say we had a temperature of 18 degrees for the dry bulb, and the wet bulb was, let's go with 15 degrees. So 18 minus 15 we know is 3 degrees Celsius. That means the difference between the wet and the dry bulb reading is 3 degrees Celsius. And we knew it was 18, so we can go to our table here, and you can see 18, 3 degrees Celsius off, so our relative humidity would be 72%. Now remember, it's referring to the relative humidity, so that is not the actual amount of water in the air, it's the amount relative to how much the most amount, or the largest amount that the water or the air can hold. Remember, warm air always holds more water than cool air, and so since we want to have a little bit warmer air, you can actually get a lot more water inside that air. So this actually wraps up the review for this upcoming test. Just a couple things I want to remind you of. Remember, all tests have questions that test not only the recall of information, but using that information. So you need to make sure you look through your investigations. Think about what the purpose of those were and how the claims and evidence explain what happens during those. Claims and evidence is always a good place to look for extra guidance on that. Remember, there's also a set of extra problems in the book that are at the bottom of the study guide or on the right-hand side of the study guide. Make sure you take a look at those. Those will also tell you a lot more information. If you have any questions, you can ask them on the My Big Campus website. I will have a discussion page that you probably found this on, and you can go ahead and post them on there.